Hi, this session regarding to calculation of space complexity for given problem statements algorithm. The space complexity is the function which is explaining the amount of memory space consumed by an designed algorithm for given problem statement based on the amount of input which is taken by the algorithm, and also which is not only calculates the space used by the input values, which is not only consider the input size, and also which is considering the memory space using by the variables used inside the algorithm. These variables will be consuming some memory space during the algorithm's execution. So the extra space or temporary space is allotted to the variables during the execution. So the total space complexity is defined as the combination of auxiliary space consumption and space which is used by the input size. Sometimes the space complexity is ignored because the space used by the algorithm is minimal. For example, nowadays all the systems are developed with large memory. For example, you see, whenever we are using the system, the suppose when we are entering the data through the keyboard, that data will pass from the keyboard into RAM. Then from the RAM it will send to the microprocessor, right? The microprocessor will have one of the memory cache, then which is also having another one unit, core. That core will execute the data, that means perform the operations. So whenever we are sending the data, I mean pressing the key, that data will pass into RAM. Suppose I'm entering the 2, that the 2 will store in the RAM. Again, if I want to enter 3, 3 also will enter into the RAM. Then if I entering the 4, 4 also enter into the RAM. Now I want to add these three numbers. First, what it will do, the 2 will send to the cache memory, right? And plus also we have entered, am I right? So plus also will be stored in the RAM. So 2 will transfer to the cache memory, then plus will send to the cache memory, then 3 will send to the cache memory. So from the cache memory, then it will send to the core. Then core will perform the addition operation. That added value again store into cache, again store into cache. Now the cache memory gets the third value, 4 4 and plus symbol. So now already 5 is stored in the cache. Now 5 plus 4 again sent to the core, then core will return the 9. Core will return the 9 from the cache memory. The 9 will return to the RAM. So now 9 is returned to the RAM. So from the RAM again it will display to the monitor. It will display to the monitor. After this, if you press the save button, then it will save into the HDD. So this is the process is carrying out when we are performing the operations, arithmetic operations, or whatever operations. So earlier days the RAM size came in the form of MBs. Okay, very low MBs like 32 MB RAM or 64 MB RAM, like that. And also cache memory came in the form of 128 KB or 256 KB. But nowadays the memory size is available for available I mean more memory space is available for cheap rate. For example, 4 GB of RAM and 8 GB of RAM, and also cache memory is also available. So this is KB earlier, this is MB, now we are getting the GBs. So cache memory earlier it was available in the form of KBs, now we are getting 512 MB, right? So the highest I mean more memory is more memory devices are available for cheap rate. So this space complexity is ignored due to availability of large memory devices for cheap cost, low rate. So space is not considered for them, but as a software engineers we should know how to calculate the space complexity for given algorithm. The example one here, the method is performing the sum of n numbers. Here, for sum of n numbers, how much space is needed? Here it is taking the one space for assigning the value into sum. For example, here we assume the sum is stored in this location. Sum is stored in this location, that location value may be 1000. So now some value is 0, some value is 0. Then we are having one more variable I equal to n, I greater than equal to 1. So here we can say n equal to 2. So n equal to 2. So here 2 greater than or equal to 1 condition is true, then I decrement. So now sum is calculated for value 2. So now the sum value equal to sum plus 2. So here sum is already 0. So 0 plus 2, 0 plus 2 equal to 2. So which is assigning into the same location. So this value 2 is overwriting into the sum value, right? So the same location is used for storing the 2. So now the 2 is overwriting in the same memory location 1000, the variable stored in that location sum, right? Then I is decremented, it is going back. Now I value is 1. So 1 greater than or equal to 1 condition is true. Now it is coming again, sum equal to sum plus I. Now sum is already 2, then I value is 1 equal to 3. So this 3 is overwriting on the same variable. So 2 is overwriting as 3, right? So now same location 3 is written in the same location, 3 is written in the same location by overwriting 2, right? So the same memory location is used again and again for n times. So the space consumed for this step is only one space. That's what, for input value n is constant which is consuming the space of order of 1, so which is denoted order of 1. So if the value is constants, the auxiliary space is here the variables which is consumed during the execution. So this is the auxiliary space which is consumed during the execution. N times it is consuming, but which is consuming only only one space consuming for n number of times. So same memory location is used, so that is total space complexity is order of 1. Second example, suppose if I want to store the n number of elements into array, right? I want to store n number of elements. Here my n is 5. I want to store 5 elements in the memory space. How much memory location is needed, right? 5 elements means here 5 elements are 2, 8, 7, 6, 0. So I want to store this 5 elements. So here I am declaring one array, right? I am declaring one array integer number. So I am declaring, so here my array name is number. So first index I am storing the value 2, I am consuming. So this is the memory location, you may assume this is 1000, this is memory location 1004, this is memory location 1008, this is memory location 1012, this memory location 1015, because integer is consuming 4 bytes. Okay, so 2 is stored here, then 8 is stored here, 7 is stored here, 6 is stored here, 0 is stored here. So we are consuming, this is one memory location, this is another memory location, third memory location, fourth memory location, fifth memory location. So to store 5 elements, I am consuming 5 number of memory locations. So for n number of inputs, I am consuming n number of memory locations. So my space complexity is order of n. I hope you understand this. Then to store two-dimensional array of numbers, two-dimensional array of numbers. Two dimension means we will have rows and columns, rows and columns. So here the number of elements will be always number of rows data and number of columns. So here if your row is n and column is n, you will have n into n number of memory locations, elements, n into n number of elements. For example, you see the rows 1 2 3, here columns 1 2 3. So you have 9 elements, you have 9 elements. So to store the 9 elements into memory locations, you are in need of 9 memory locations. So for each data you need one memory location. So here the row size is 3, column size is 3. So this is the n equal to 3. So n equal to 3, row equal to 3. So your complexity is n square, order of n square. Space complexity, space required for storing the two-dimensional array numbers, we need order of n square space. Then example 3, here we are using the recursive function. So whenever we are using the recursion, we should use stack memory, we should use stack memory. So here the stack memory is using two operations, stack memory is using two operations. One operation is pushing, that means inserting the value into stack. Another one is deleting the value from top of the stack, pop. Okay, two operations. Memory locations will be represented 0 1 2 3, it will keep on go. Right now, whenever we are using the recursion, we will, recursion means the method or function called by itself. So here we are adding the n numbers, we are passing the value n. For example, here I am using the 4, n equal to 4, the 4 less than I or equal to 0, which is false. So it is returning n plus add n minus 1. For example, right here, if I am having the stack like this, if I am having the stack like this, right, it will enter the first statement. So n less than or 4 less than or equal to 0. So now this will get into the 0th memory location. So 0th memory location, 4 plus n value 4 plus add of 4 minus 1 3. So now 3 is passing into the function, 3 less than or equal to 0, which is false, which is coming out of the loop. So which is returning the this value. So n is now 3 plus add of n minus 1, 3 minus 1 2. Then still operation to be performed, right? Then now again it is calling add method. So now n minus 1, 3 minus 1 is 2. So 2 is passing, so 2 less than or equal to 0, which is coming here. So 2 plus add n minus 1, 2 minus 1 1, right? Again the value add method is called for 1. So 1, so 1 less than or equal to 0, which is false, which is coming out of the loop. Return n value is 1 plus add of 1 minus 1 0. Now again add of 0 which is calling, so 0 less than or equal to 0, condition is true, returning the 0. So here we are getting the value 0, right? So now we have to substitute this value 0 into all the memory locations, you look at this. So this value is for add of 0, so we got the value for add of 0. So now you substitute this value by moving, I mean pop up, so your pop up and you are substituting this value. So what will be happen, so this will be pop up, then it will be substitute here, so 0 will be substitute here, so 1 plus 0 will become 1. So now this will be pop up, it will be substituted here, right? So now 2 plus 1, 2 plus 1 is substituted here, then it will become 3, right? 3 will be pop up and substituted here, 3 plus 3 becomes 6, so 6 is pop up and substituted here, so 4 plus 6 equal to 10. So now 10 is substituted here. So how many memory locations we have consumed here? 0th memory location 1 2 3 4. Okay, so what is my n size? N is 4, right? So n is 4, my memory locations I have consumed for n plus 1. Okay, so big O of n plus 1, here when your n is getting increasing, you can ignore the lower order term, so you can ignore the lower order term, so finally you are getting order of n memory locations. I hope you understand the concept. Then example 3, here we are adding the numbers by using the method sum of n numbers by using the method. So here it is taking one memory location, which is also taking one memory location, then this is constant order of 1, then this is taking again, it is running for n times, but memory locations in terms, here we are pass this method, this statement is sum equal to sum plus 2 sum, this is the method, and I comma I plus 1. So here my n value is 2, assume my n value is 2. If my n value is 2, then here I equal to 0, initially sum is also 0, right? Sum is also 0, then plus 2 sum of I is 0, then I plus 1 is 1. So now we are passing these values here 0 comma 1. Here we didn't use any assignment variable to store the value, so we are not consuming any memory location to store the value, just it is executing. This is the variables, these are the variables which are consuming memory location during the execution time. A plus b, so 0 plus 1 1 is returning to here. Okay, 1 is returning to here, this is the value 1. So finally we are 1 is storing in the same memory location. For example, initially sum is 0, then now which is overwriting by 1. Okay, now the I value is incrementing, then I equal to 1 less than n, 1 less than n, true. So now I value is 1. Okay, here I value is 1, so I value is 1 is passing, then I plus 1 is 2, so 1 comma 2 is passing here, so 1 comma 2, so 1 comma 2, 1 plus 2 is 3, so 3 is returning to here, so 3 is returning here. So already sum is 1 plus 3, then 1 plus 3 equal to 4, the 4 is overwriting in the same memory location. Now I is incremented by 1, so now I is 2, so 2 less than 2, condition is false, then it come out of the loop, then returning the sum value is 4, which is written here. So here the same memory location is used by this sum variable, so it is consuming order of 1 space, but approximately order of n calls to the to sum, but that calls are consuming only same memory location for the sum variable, so which is consuming order of 1 space. So with this, the space complexity session is over. Thank you.